Good morning, dear students. Last session we have talked about the allowable stresses in concrete, in fact, pre-stressed concrete. So we are actually discussing the high strength concrete properties, where we have come across different properties. I'll just run through the slides what we have discussed about high strength concrete. So we have talked about very basic information like constituents of concrete, and also aggregates, and then cement, then water, and admixtures. Likewise, we have talked about very basic information regarding the constituents of high strength concrete. Then came to the properties of hardened concrete we are now discussing about. So with that, strength of concrete is the first one to discuss, and then among the strength of concrete you have uh, compressive strength we have discussed, tensile strength, withdrawal strength properties we are discussing about, and then stiffness of concrete also being discussed, then durability property, for which sulfate attack and all, and then high performance concrete, different types of high performance concretes also we have discussed, and then the permissible stresses in concrete are being discussed in the last session. Now we are talking about shrinkage property of pre-stressed concrete. Okay, so what does mean by shrinkage of concrete? You might have come across in RCC, like reinforcement concrete. What does mean by shrinkage of concrete? So shrinkage means contraction due to loss of moisture. So this is what is called the shrinkage. So we are adding some water cement ratio. As per water cement ratio, you are adding some water to the concrete. So some water is utilized in the hydration process, and some water will stay in the voids to fill it up. So what happens with this property of shrinkage? So as the process of the hydration, heat of hydration is going on, some water will be evaporated. Uh, so we lose the moisture. So because of that property, we have the shrinkage of concrete property. Okay? So some water is utilized in case of reaction, for the reaction purpose, and then some water will be utilized for the the fill up of the voids. So based on that concept, we have two causes for shrinkage. Okay, so this is what the purpose of water in the concrete. What goes on in the concrete with the water. Okay, so study of shrinkage is important reason to calculate loss in pre-stress. So there are different losses in pre-stress that we will talk about in the further sessions. So the loss in pre-stress due to shrinkage is also important. Okay, so that is due to loss of, one reason is loss of water from voids. So that we call drying shrinkage. So as I said, now the water that is mixed in preparing concrete, according to water cement ratio, maybe 0.4 or 0.5 or zero point 0.6, whatever it is. The water is lost, whichever is there in the voids will be dried up as time progresses. Okay, so that is called drying shrinkage. And the other one, reduction of volume during carbonation means uh, carbonation means the reaction that when the water is added to the cement, the reduction in volume, that means water is utilized in the carbonation process, and we lose the water. Some new components will be formed, so that is why volume will be reduced. That is called autogenous shrinkage. Okay, so there are two causes for shrinkage. One is drying shrinkage, another one is autogenous shrinkage. Okay, so there is a diagram given here. If you can observe that the variation of shrinkage strain, we calculate the shrinkage property. This is a property, and you have to quantify that how much. So we talk about in terms of strain. Okay, how much a reduction in the dimension. Okay, that is strain. So there is a graph drawn here. If you see versus time versus strain. As the time progresses, the strain values are becoming constant. Okay, there is no change as time progresses. Okay, so you can see this is the strain at the initial stage, and then after some time, this is the strain value. Okay, and after some time, this is the strain value. And later on, as time progresses, this increase in strain is reduced, right? So see here, this is the increase. This is the increase. And further, if you take any later time, the strain is almost constant. Okay, same for whatever time you see. Maybe after 1 day, maybe after 10 days, after 1 month. Likewise, the strain is becoming constant. Okay, so the shrinkage, uh, the drying shrinkage, that is what is this graph shows. The shrinkage strain increases, shrinkage strain increases at a decreasing rate with time. As time progresses, the shrinkage is increasing, but the rate of increase is decreasing. Okay, right. So that is what is the shrinkage estimate to calculate loss. Okay, got it. Let us go to the next content. Like creep, shrinkage also depends on several factors. The shrinkage strain increase with the increase in the following variables. So we are going to see now uh, with the following variables, if they are increasing, shrinkage also increases. For example, ambient temperature means the exposure of concrete to the temperature. So if the temperature is less, maybe some 10 degrees or 20 degrees, the shrinkage will be less. If the temperatures are 40 degree, 50 degrees, then shrinkage will automatically will be increased because the drying process will be very high. You lose water, much water you lose because of the temperature. Right? The temperature gradient in the members means the change of temperature also matters. Temperature gradient and water to cement ratio. If the WC ratio is high, so for example 0.6, the highest value, compare with the 0.3, for example. So what does this mean? You are adding more water, so you are going to lose more water. You are adding less water if it is 0.3, less loss in water. So less shrinkage. So more the water cement ratio, more the shrinkage strain value. Okay. Whereas the shrinkage decreases with increase in the following variables. These are the variables which decrease the shrinkage ratio. So these four will increase the shrinkage ratio, shrinkage strain, whereas these three will decrease them. Right? So you can see age of concrete. Okay, age of concrete. As the age of concrete increases as time progresses, just now we have seen the graph. As time progresses, the shrinkage strain is going to reduce. Okay, so similarly, relative humidity. Okay, if the humidity is high, now the drying process will be reduced. Okay? Similarly, volume to surface area ratio. More surface area, if the surface area is volume divided by surface area, volume by surface area, that means something like perimeter. Okay, V by P ratio. This is increasing means what? Perimeter is reduced. Okay, means the area of the exposure reduces. Okay, if the area of the exposure is reduced for a member, then if the exposure is reduced, drying process also, shrinkage process also reduces. For example, if you take a concrete member, this portion, this part of the top surface will be a part of slab, for example. So these three surfaces are faces are exposed to atmosphere. Okay, so that's why the shrinkage process will be very. If you say, for example, if you if some member is taking this into that, if you are embedding something into this, so only two faces are exposed. Okay, bottom and this one. So that's why the shrinkage comes down like this. Okay, and shrinkage strain also depends on the type of aggregate also. Okay, so this is about the parameters that increase the shrinkage, and the parameters that decrease shrinkage. Right. The IS code in class 624 gives the guidelines to estimate shrinkage strain. So a detailed estimate is given in class 624. Open your IS codes and go to 624. I'll just show you the IS code also, wherein the shrinkage strain calculation is presented. Okay, 624 you have to go. Okay, so this is clause 624. You can see it here. So 624 talks about shrinkage. So where 6241 gives you the definition and how to estimate total shrinkage. 6242 autogenous shrinkage. Then 6243 drying shrinkage. All these are given. Even 6244 how to calculate shrinkage at a particular time, maybe after 1 year or after 2 years. Also, the drying shrinkage. This is autogenous shrinkage at particular time. Similarly, drying shrinkage after a particular number of days, or after 6 months or after 1 year. Likewise. So, a detailed estimate is given in terms of formulas. Complete Clause 624 talks about how to estimate shrinkage. What is a shrinkage? What factors influence it? All that information is available in 624. That I'll present to you now. Just open your IS codes, just follow the IS code. Okay. So the how to estimate total shrinkage. There are two types of shrinkages, as I told you. Okay. So total shrinkage is combination of autogenous shrinkage, which is because of the chemical reaction, drying shrinkage because of the evaporation of water from voids. Okay, so this is autogenous drying. D refers to drying, A refers to autogenous. Okay, epsilon strain, C refers to concrete, D refers to drying, whereas A refers to autogenous. Okay, epsilon concrete, strain in concrete. So that is due to shrinkage. So drying shrinkage, autogenous shrinkage. So total shrinkage, epsilon C S. Okay, concrete S means shrinkage strain. Okay, C D C A. Right. So how to estimate the autogenous shrinkage? I have just taken everything from the IS code, which is class 6242, right? So total value of shrinkage in the absence of the data, maybe field data or laboratory data, these are the values that you can straight away take for the estimation of the autogenous shrinkage, epsilon CA, this is epsilon CA. Okay. So if you are using M30 grade, take strain value epsilon CA is equal to 35 into 10 power 6. Okay. So autogenous shrinkage is a linear function of concrete strength. So it varies linearly with the concrete said. Okay, it should be considered specifically when new concrete is cast against hardened concrete. Okay, that is what is autogenous shrinkage. Okay, so the major part develops in the early days after casting because the most of the reaction happens within 28 days, right? So that's why we are allowing the concrete to gain the fullest strength till 28 days. So during those 28 days, the reaction happens so that it gains strength. Okay, so almost 99% of the strength is achieved in 28 days. Hence, early days only this autogenous shrinkage is effective. So this is the table that gives you the value of autogenous shrinkage straight away, a number. Okay, in terms of grade of concrete, as it varies with the grade of concrete. So for M60 it is 95. As it said, it varies linearly. You can even estimate for M70, M80 also with the extrapolation. Okay, the values that if you require and in the absence of any data. Okay, you just extrapolate these values for even M80 grade also. Now comes to drying shrinkage. Okay, it develops very slowly. Okay, because it has to, the water shall be evaporated through the concrete, very inner part of the concrete, core portion of the concrete. Takes a lot of time, very slow process. And the final value of drying shrinkage, final value, may be taken equal to kh times epsilon cd, and epsilon cd values shall be taken from this table. Okay, uh, uh, these values are expected mean values with a coefficient of variation about 30%, means the values will vary roughly about 30%. Okay, so these are drying shrinkage values. We have seen how to estimate autogenous shrinkage values. Now it is to estimate drying shrinkage. So you can see that it is depending on humidity value. So if your the location where you are working, where your structure is having 50% humidity, relative humidity, use these values. If it is of 80%, use these values. Okay. And for any other grade of concrete, say these are given for 25, 50, 75. The other designated grades may be obtained by interpolation. Okay, so this is the bottom line of those values. Wherever it is specified, you can always get a value by interpolation. So for example, I want it for M60 grade. Okay, so you have 50 value and 75 value. Interpolate the value in between. Okay, and so that is estimated by and shall be multiplied with a factor kh. These are epsilon cd values, like say for M50 grade, 420 into 10 power 6 into kh. And what is kh value? That should be taken from this table. Okay, depending on the size of the member, because drying shrinkage depends on the exposure, area of exposure of the member. So that's why this value is linked to the exposure parameter, that is called kh. So how you estimate the exposure? By notional size called h naught. So you have to estimate a notional size. There is a formula for this to get h naught. So if your h naught value is 300, means only 75% of this value must be used. Means this value shall be multiplied with 0.75. 75% value. The h naught value is less, means your drying shrinkage value is very high. So as the H naught value increases, values are reducing, and the maximum that happens is only 70%. Okay, 70% to 100% it varies, right? So, and coming to 6242 clause, these are final values of shrinkages, autogenous and drying. So for example, if you are interested in finding autogenous shrinkage at a particular time interval, say for example after 1 year, what is the shrinkage value? You can get it from this formula. Okay, so where you have to estimate the epsilon ca value depending on time by epsilon ca multiplied by a factor called beta. So what is beta? 1 minus exponential of minus 0.2 square root of t e power minus zero point 0.2 root t. T is in number of days. So say if you want to estimate epsilon ca value after, for example, 1,000 days, okay, you can get it by simply substituting t as 1,000, get a beta value, substitute beta value, and epsilon Ca are final values which you have already have a table of value. Okay, so take epsilon Ca from the table given in 6242, this one, and estimate beta from this formula, get epsilon Ca at a particular time. Okay, likewise, even for drying shrinkage also, if you want at a particular time, then simply multiply this value which you calculated in 6244 by a factor called beta, that is by a formula, given by a formula. Okay, and now as I said, what is H naught is given here, 2 times area of concrete by perimeter, cross section by perimeter, cross sectional area by perimeter, which is exposed to environment or exposed to drying. Perimeter means not the sum of all four sides. Okay, whatever side it is exposed. If these three sides are exposed, just add these three. So if it is 300 by 300, 300 plus 300 plus 300. So 900 is perimeter, which is exposed to the environment. Cross section area 300 into 300. Cross section of the member 300 by 300. So likewise, you have to estimate the and multiplied by 2 will give you H naught value, which is to be used even in getting beta, and also even to get a value of KH, you have to estimate H naught. Okay, so this is how we get the shrinkage values. Maybe if you are interested in final values, there are final values available directly, or even at a particular time, if you want, you can estimate. Okay, so this is about today's lecture on shrinkage of concrete, how to estimate in detail, and what factors are influencing the shrinkage of concrete, and what are all types of shrinkages that you have in estimating total values, right?